So there are a couple of practical examples of the F equals BIL force that we should be aware of. One is the electric motor. Now I haven't got a demonstration of that, but I will link to one in the description below you can click on. And the other is the loudspeaker. Now we have a simple homemade loudspeaker here. I didn't have a recent video here during lockdown, so this is one that I took about 15 years ago. So it's quite an old video, but you can still see it reasonably well. All we've done is made a paper cone, just out of a bit of A4 paper, cut it into a semicircle, folded it up into a cone, and then cut another cylindrical piece of paper and attached that to the bottom of the cone, around which we have wrapped a length of enamelled copper wire and stuck that down to the cylinder. And then we've just taken off the insulation from the end of the wire, so it's rubbed off the enamel insulation at the end of the copper wire and attached it to a signal generator. Now we've simply then dropped our loudspeaker cone over just a basic bar magnet and attached to the signal generator. And the signal generator, we can actually place any frequency of electrical signal through the wire. Now if you look at the top there of the bar magnet, at least at the top of the bar magnet, as the loops of magnetic field come out of the top of the bar magnet and around to the bottom of the bar magnet, at least some of those magnetic flux lines are going to pass through the wire at 90 degrees. Basically they're going to be perpendicular to the current at the top, and you can see that in the animation at the top right of the screen there. So the animation shows the magnetic flux lines coming out of the top of the bar magnet, passing through the coil of wire pretty much at 90 degrees to the current, and what that means is that that wire is going to experience a force. So what we will do is turn on the signal generator, and at low frequencies you can clearly see the coil and the loudspeaker to which it's attached move up and down. So as the direction of the current changes, the direction of the force on the wire changes, causing the cone to move one way and then the other way, and at low frequency that motion is very, very visible. We're going to gradually increase the frequency, and we'll see the frequency of the oscillations increase. Notice then the frequency of the sound wave that you can hear also increases. The frequency of the sound wave is matching the frequency of the alternating current which is producing it. Why are we getting a sound wave? Well, as the cone oscillates up and down, it's moving the air inside that cone up and down, and that's producing a longitudinal wave which is then transmitted through the air. And of course that's what sound is, a longitudinal wave. A longitudinal sound wave is what we've got. We can use the signal generator as an amplifier and just connect an MP3 player, a music player through it, and if we do that, we see here, we'll hear some recognisable sounds. All that's happening here is the frequency and the amplitude of the electrical wave is being constantly adjusted, and that's then producing again different frequencies, different amplitudes of sound, which we're hearing then as recognisable sounds from our loudspeaker. And you can see that works quite well. So how could we explain this, explain what's happening? Well, let's have a look. So first of all, an alternating current will flow from the signal generator. The current in that coil then will experience an F equals BIL force due to the magnetic field. The direction then of this force is given by Fleming's left-hand rule, of course, and is perpendicular to both the current and the field direction. As the direction of the current reverses, so the direction of the magnetic force on the wire will reverse. So that will cause the coil and of course the cone to which it is attached to oscillate up and down, producing a longitudinal sound wave in the air. And of course the frequency of that sound wave must be the same as the frequency of the alternating current which has produced it.